Hello again. All right, so today what we're going to do is we are going to go through um, Chapter 5, Section 2 specifically. We're going to take a look at some of the word problems that you are responsible for understanding in this week's test or in the next Unit 2 test. So these word problems are taken from Chapter 5, Section 2. If you look at this folder, there is a printable worksheet available that has all of the questions, the 10 questions that I will go through in this presentation. It's included in this week's assignment folder in Blackboard. All right, so we are in Chapter 5, Section 2 and Part 7 in your course supplement. We're about to do the thing that people really don't like, which is word problems. So there are some things that I want you to keep in mind. The very most important thing is to take small steps. I fully understand that some of you will be able to read a problem and actually know the answer, but most of you will read the problem and not know the answer right away. This is absolutely fine. My suggestion is that you identify the type of problem that it is and what formulas you may need. Most of what we'll be doing are called total problems, in that you will be given a total and some parts to find. If there is an unknown, identify it, name it, call it out, write that part down. Write the relationships as an equation. We are actually looking for the equation in much of this, and then solve that equation. I would add one more to this, which is be certain you are answering the question that is being asked, not just finding X. All right, here's our very first word problem. Here we are. Dave earns $50 less than twice the amount that Steve earned last week. Together, they earned $1,330 last week. How much did each of them earn last week? So, if you need to, take a moment and read it again. And I'm going to ask some questions. The first question is, can you identify the total amount? For this problem, the total amount is $1,330. That is the total that we're talking about. This total is broken down into two people's pay. The first person is Dave's pay. Oh, sorry, first person is Steve. Steve's pay is going to be first, and then we're going to talk about Dave's pay. Now, I started with Steve because Dave earned $50 less than twice the amount that Steve earned. So Dave's amount is a relationship to Steve's. Since Steve is who we're basing Dave's amount on, I'm going to call Steve X. I don't know how much Steve made, but whatever amount Steve made, Dave earns $50 less than twice that amount. How do I write that algebraically? Well, 50 less is minus 50, so we're going to minus 50 from twice the amount Steve earned, or 2x minus 50. These two parts together make 1330, or 1,330. This gives us our equation. I can take the amount from Steve, which is X, and if I put that together with the amount from Dave, 2x minus 50, I get the total of 1,330. Now from here, we simply work the algebra. So x plus 2x is 3x, minus 50 is 1,330. I'm going to add 50 to both sides to get 3x is 1,380, and then divide both sides by 3 to get x is 460. X, since we named it, is what Steve made. So Steve made 460. Dave makes twice this minus 50, or 2 times 460 minus 50, which is $870. As a reminder, I'm going to reread the final question, which says, how much did they each earn last week? And since I need to know the amount for each of them, both of these amounts are my answer. I'm also going to double check it because I know that these two together, the 460 and the 870, must add up to be 1,330. So I'm going to go with that, and 460 plus 870 is 1,330. Taking a look at the second word problem. We see that Sarah is considering leasing a building with 6,100 square feet. Sarah needs 1,300 square feet for offices and twice as much warehouse space as showroom space. What size in square feet should the showroom be? All right, so I have a total here, and that total is 6,100 square feet. That total is broken into 3 parts. The first part is the 1,300 square feet needed for the offices. The second part is going to be the showroom space. And the third part is going to be the warehouse space. These 3 pieces together are what make up the total square footage of the building of 6,100. Now, we already know that the office space is 1,300. Then we see by reading that twice as much warehouse space is needed as showroom space. Twice as much warehouse space as showroom space. Since the showroom space is what our warehouse is based on, I'm going to let showroom equal X, and then the warehouse space would be 2X. The relationship between the 3 parts is that if we total them up, we should get 6,100. So our equation will be 1,300 plus X plus 2X is 6,100. Combining like terms, I get 1,300 plus 3X is equal to 6,100. Subtracting the 1,300 from both sides, we get 3X is 4,800, and X would then be 1,600. X is the value of the showroom, and it also answers the question asked. The showroom would be 1,600 square feet. I don't need to find the warehouse, so this answer is all I need. Problem number 3. You're moving, and you've rented a truck to help you with your move. Trailside Rentals charges $75 a day, plus an additional 45 cents each mile. You're going to need the truck for 3 days. If you have budgeted $400 for the truck rental, how many miles are you able to drive? So we have a total. That is our total budget of $400. That total budget is broken into 2 parts. We have the rentals daily, and we have the number of miles that we travel. Based on the information, the daily rental is $75 per day, and we're going to keep it for 3 days. So that will be 75 times 3. Our charge per mile is 45 cents per mile. I don't know the number of miles, so I'm going to use an M there for miles. And I have to keep in mind that 45 cents would be a decimal. So I'm going to do 0.45 times the number of miles. These 2 in the relationship, when they're totaled, have to add to 400. So my equation will look like 75 times 3 plus 0.45 m is equal to 400. Simplifying my calculation, I get 225 plus 0.45 m is the 400. Subtracting 225 from both sides, I have 0.45 m is 175. And from there, I would divide both sides by the coefficient 0.45 to get m is equal to 388.8 miles. Now, the question says, how many miles can you travel? And this piece is a little bit tricky. If I travel 0.8 of a mile, I'm actually going to get charged for 389 miles. I can't get charged for 389 miles because that would be over the amount of money in my budget. Now, granted, in the real world, we would likely just scrounge our change jar, but this is not the real world. This is math. So I'm going to take any additional decimal mileage and simply cut it off. So I'm going to stay under budget if I can travel 388 miles. And that will be my final answer. Problem number 4 says if you open an oil change shop, your fixed cost will be $1,300 per month, plus an additional $8 in materials per customer. Your plan is to charge $28 for a lube oil filter. How many customers do you need in a month to break even? So, breaking even basically means that you don't go over the amount of profits and you don't go under the amount of profits, that you meet your fixed costs. Since our fixed costs are $1,300, we will start with our total there. So our fixed costs are $1,300. That means we always have to spend $1,300 to survive in the business. We're going to make $28 per lube oil filter on charging, but it's going to cost us $8 in materials. So if you've got to buy an oil filter, if you've got to purchase the oil, all of those things are a cost to the business. We're going to charge $28 times the number of oil changes we're able to do. So this will be 28x, $28 per customer. It's going to cost us $8 per customer. And since it's going to cost us, we're going to lose that $8. So of the $28 we're going to bring in each customer, $8 is going to go out. This gives us an equation of 28x minus 8x has to equal $1,300, or 20x is equal to 1,300. That means when we would divide each side by 20, we're going to get x is equal to 65. What this tells us is that we would need 65 customers in order to make our fixed cost or to make our rent for the month. For problem number 5, we have another total type problem. Beth, Rudy, and Sam are going to go shopping. Together, they spend $68. Rudy will spend 3 times as much as Beth. Sam will spend $3 more than Beth. The question is, how much did Beth spend? As before, we want to find our total. Our total is that together they spent $68. That $68 is split between 3 people. Our first person is Rudy. Our second person is Sam. And our third person is Beth. Of these 3 people, both Rudy's amount and Sam's amount is given to us in terms of how much Beth spent. Since I don't know how much Beth spent, I'm going to let Beth be X, and then Rudy would be 3 times that. Sam spent $3 more than Beth, or 3 plus Beth's amount, which means Beth has to simply be our X. Once these 3 are filled in, I can set up my equation. My equation is going to be the total of all 3 of the red boxes, so 3x plus 3 plus x plus x has to add up to be my total of 68. Combining my like terms, 3x plus x is 5x plus 3 is equal to 68. I'm going to subtract the 3 from both sides, giving me 5x is 65, and dividing by 5, we have x is 13. X is the amount that Beth spent, so we now know that Beth spent $13. The question asked was, how much did Beth spend? We know that Beth spent $13, so that is our final answer. In the 6th word problem, we have Jeremy and Susan opening a card shop, spending $950 ordering 600 cards from Cards R Us. Their nature cards cost them $1.50 each, and their humor cards are $1.75 each. How many of each style card did they order? Now this one is a little bit tougher. We actually have 2 different totals. We have an order of 600 cards for $950. We know the total number of cards ordered, and we know the total amount of money spent. Those totals are split between 2 different types of cards. On one hand, we have the nature cards, and on the other hand, we have the humor cards. We do not know how many nature cards they ordered, so I'm going to call that just the letter N. But whatever they ordered for nature cards, humor cards have to be the rest of the way to 600, or 600 minus N. This gives us the number of nature cards and humor cards written in variable form. We know that the nature cards cost $1.50 each, and we know that the humor cards cost $1.75 each. We're going to use these pieces of information to write the equation. Now, if I multiply that $1.50 by N, the number of nature cards, I will have the amount that they spent on nature cards. If I multiply 175 by the 600 minus N, I will have the amount of money they spent on humor cards. Putting those 2 together, those 2 amounts, I will get the total spent, or $950. So this is the money equation. $1.50 times N plus 175 times 600 minus N is equal to $950. Simplifying this equation, I'm going to distribute the 1.75 first. So I'll have 1.5N plus 1050 minus 1.75N is equal to 950. Now I'm going to combine my like terms. My like terms here being the 1.5N, whoops, not this line. Where's my eraser? There we go. Being the 1.5N added to the minus 1.75N. This gives me a negative 0.25N plus, what's that doing? Plus 1050 is equal to 950. Then I'm going to subtract 1050 from both sides, giving me a negative 0.25N is equal to a negative 100. And from there, I will divide both sides by the coefficient of a negative 2.5 to get that my n value is indeed 400. This tells me that the number of nature cards sold was 400. And that means that humor has to be 600 minus that, or 200 cards left for humor. Double checking to make sure I'm answering the question that was asked. I see how many cards of each style did they order, and I know that there were 400 nature cards and 200 humor cards, so that is indeed the final answer. All right. Now we're going to take a look at problem number 7. Word problem number 7 is very similar to word problem number 6. REI sells a 35-liter backpack for $125 and a 22-liter backpack for $95. If they sell 328 backpacks online and generate $34,430 in sales, how many of the 35-liter backpacks, those are the larger ones, did they sell? So again, we have two parts to our total. We know that altogether they ordered 328 backpacks, and that altogether their sales were $34,430. So those two totals are broken down into two parts. The first part is those of the larger or 35-liter backpacks. The second is those of the smaller or 22-liter backpacks. Since I don't know the amount of either, and they've asked me about the 35-liter backpacks, I'm going to let the 35-liter backpacks be my X. Now, that means that the 22-liter backpacks have to be the rest of the way to 328. So whatever X is, if I take that number away from 328, I will have the number of 22-liter backpacks. What about the sales? What about the money? As a reminder, the 35-liter backpacks are $125 each, and the 22-liter backpacks are $95 each. With this information filled out, I can now figure out the equation. The equation is the money from the 35-liter backpacks added to the money from the 22-liter backpacks, and together that has to total all the money, or $34,430. Using my solving skills, I'm going to distribute the 95 across the parentheses to get 125x plus 31,160 minus the 95x is equal to 34,430. Simplifying by combining my like terms, ooh, what was that? I'm going to do 125 minus 95 to get 30 plus 31,160. Subtracting the 31,160 from both sides, I get 30x is equal to 32,070. And dividing by 30, I have x is equal to 109. Since x is 109, I know that they sold 109 35-liter backpacks. That was the question that was asked. How many 35-liter backpacks did they sell? So I have completed the problem and answered the question. All right. Now, we're going to switch tracks a little bit here with the last three problems. Problems 8, 9, and 10 all have to do with the way that money is divvied up. And it is very similar here it is very similar in terms of process, but there's a couple of things we need to tweak, all right? So let's get into this a little bit. This year, a $45,000 college scholarship is being divided among the top 3 contestants. The winner, receives 5 times as much money as the second place applicant. The second place applicant is going to receive 4 times as much as the third place applicant. So we need to determine how much each contestant is going to receive. Now, like all of our problems before, there is still a total here. The total is the $45,000 in scholarship. So that $45,000 in scholarship is split between 3 different sort of place levels or award levels. There's the first place award level, the second place award level, and the third place award level. The third place award level is our smallest, and second place is based on how much third place got, and first place is based on how much second place got. So I'm going to put my X at the smallest payout, and the smallest payout is third place, right? What we know from the reading is that the second place winner receives 4 times what the third place did. And if third place is X, then second place would be 4 times that, or 4X. We are also given the information that first place receives 5 times whatever second place did. Since second place was 4X, first place will be 5 times that. Once I have this row filled in, I can now put it together to get my total. So I will have 5 times 4X plus 4X plus X is equal to 45,000. Do you see those ones I put in front there? Those ones are because there was only one first place winner, there was only one second place winner, and there was only one third place winner. Those ones are important a little bit later when there's more than one in each place. So I have 20X plus 4X plus X is 45,000. If I put those together, I will have 25X is 45,000. Dividing both sides out by 25, the coefficient of X, I have that X is worth $1,800. Now, what does this mean? This means that your third place winner will get $1,800. That is the lowest award in this scholarship fund. The second place winner is going to get 4 times that amount, or 4 times 1,800, which is 7,200. The first place winner is going to get 5 times what the second place winner did, or 5 times the 7,200. This is $36,000. Now think about your college fees. I believe here at Western, any one of those would be helpful, but at a private school, you're probably going to want the largest one at $3,600. $1,800 at a private school might not even cover books. Okay, so I was supposed to determine how much each contestant will receive, and I've done that. I have the first place, second place, and the third place. So this is my final answer. Good? Okay. Problem 9 tweaks this a little bit. Problem 9, we're going to use the same $45,000 scholarship fund. We're still going to have top 3, I shouldn't say contestants there. I should switch that up. Divided between the top, we should get rid of 3 because there's not 3 there. So we're going to be divided amongst the top contestants. All right, great. How did we switch it up? The winner receives 5 times as much as the second place applicant. Fine, that's the same. Each of the 3, so now there's 3 people who get the second place award, not just 1 like last time, but 3. Receives 4 times as much. Yep, nope, that's great. As any one of the 8. We got 8 people in third place. So we're going to have not 3 contestants, but we're going to have 12. So we're awarding more money. We're awarding the same amount of money, but we're spreading it out to more people. This is going to dilute it. Watch what happens. All right, so here we go. We've got 45,000. It's still split between first place, second place, and third place. But this time around, we have one person in first place. One person still gets a main award that will hopefully pay for all of their college. In second place, we now have 3 people, not just 1, but 3. And in third place, we have 8 people. I know some of you are thinking, can't we just take the 7,200 from the last problem and split it amongst the 3 people? We could. We could, but then that one person gets all of the 36,000. And to my mind, it might be better if we took some of that 36,000 and spread it out among the people below. That might be more helpful. Because Lord knows if you're in third place and you got to split 1,800 amongst 8 people, that's just like $225 a person. That probably won't even buy one of your textbooks. So let's try this method. All right. We're going to do the same thing as before. In third place, that's the smallest amount. We're going to call that X. In second place, they get 4 times that, or 4X. And in first place, they get 5 times what second place did, or 5 times 4X. So that still works. It does, however, switch up our equation. Because now we still have 1 times the 20X, but we've got 3 people getting 4X. And we've got 8 people getting X. So that leading number for each category changing is going to switch up our equation. So now I have 20X plus 12X plus 8X is equal to 45,000. If I add those up, the 20X plus the 12X plus the 8X, I get 40X is 45,000. So my X with division is 1,125. This means that the person in third place, the 8 people in third place, each get $1,125. Remember when there was only one person, they got $1,800? This is a deduction, but $1,125 would still pay for a couple of courses and books, right? At least here at Western. Second place will be 4 times this amount. So second place is $5,000. And a $5,000 scholarship would easily pay for a year, I would think, or pretty close, right? Maybe not all 3 terms, but 2 terms for sure. And then first place is going to be 5 times. How come this is off? What did I do? I got a wrong number. Hold up. Hold up. All right, so I got to do 1125, right? 45. Hold on, let me check that number. 45,000 divided by 40, 1125 times 4 is 40. Okay, I got a pen here. This is not 5,000. There we go. This is 4,500. Okay, so sorry about that error, but it's a good thing I can fix it. So 4,500, which when I multiply by 5 still gives me the 2250. Okay, that's good. Note to self, fix that problem. All right. Now, notice all of the amounts are slightly smaller, but not quite as diluted as if I would have divided 1,800 by 8 or 7,200 by 3. Matter of fact, if I would have divided the 7,200 by 3, this would have been 2,400. So they still get almost twice as much as before. Who took the biggest hit? Well, first place. But first place is the difference between 36,000 and 22,005. I mean, 36,000 for a year of school is quite a bit of overpay, I think, my opinion. All right. So there are my 3 answers with the correction. We want 4,500 on the second place. Sorry about that error. Okay. Last problem. We're going to use the same method, but we're going to tweak it slightly. So this is the same idea as problems 8 and 9, but we're taking this from a slightly different perspective. In this perspective, we have an estate that's worth $576,000, and it's going to be distributed among a wife, 4 children, and 8 grandchildren. So this is an inheritance problem. The children will receive 10 times what the grandchildren receive, and the wife will receive 8 times what the children receive. How much is the wife going to get? So we have a total amount here of $576,000. That $576,000 is going to be distributed into 3 different groups of people. The first group is the one wife, and we're assuming one wife here, not 3 of them. The second group is their children. There are 4 of these children, and these 4 children have children as well. He's got 8 grandchildren, or the estate has 8 grandchildren. Now, who gets the smallest amount? We're going to make that our X. The smallest amount goes to the grandchildren. So I'm going to put my X value where the 8 grandchildren are. I know that the children get 10 times that amount, or 10X. So I'm going to put the 10X there. The wife gets 8 times what the children get. So that's going to be 8 times 10X. These 3 categories, when added together, will give me my total. So I have one wife at 80X. I have 4 children, each getting 10 times the smallest portion, and I have 8 grandchildren, each getting the smallest portion. This gives me 80X, or 1 times 80X, plus 4 times 10X, plus 8 times X, or 80X plus 40X plus 8 is equal to 576,000. If I add those 3 like terms together, I get 128X is $576,000. Dividing both by 128, I know that X is equal to 4,500. Now, I have gotten an inheritance from my grandparents when they passed, and both times it bought me a screen door under $200. So, it happens, but yes. Yeah, both times. When one grandparent passed, I got to buy a brand new screen door because I had a brand new house. And then when another grandparent passed, it was time for a new screen door because it was like 12 years old. So screen doors. All right. So I know my X value, which is what the grandchildren get, is $4,500. The wife gets 80 times that. So the wife will receive 80 times 4,500, or $360,000. That's a nice inheritance for the wife. But remember, I don't know their ages. They're old enough to have grandchildren. And if you know anything about growing older, the cost of living, of supporting yourself, if you need any kind of assisted living situation, is just nuts. So it sounds like a lot of money. Her decision may have to be assisted living or cruises for the rest of her life. Right now, cruising is not a good idea. All right, so this is my final answer, that the wife will receive $360,000. There is extra practice of these word problems available. You will find extra practice in your supplement in pages 8 through 14. All sets you can do there. The multiples of 4 would be a good place to start. And in your supplement on pages 15 and 16, there are a list of word problems. The answers are there at the bottom. You're welcome to look them over. In Chapter 5, if you go to pages 150 to 153 and do your chapter review problems, so in your e-text, you're looking for the Chapter 5 review problems. You will find extra practice on word problems as well as the rest of Chapter 5. Your graded assignment is on WebAssign. It is Chapter 5, Section 2. Again, this will cover mainly word problems, as that is what we have done here. As always, if you have any questions or concerns, please don't hesitate to reach out to me, your instructor, or to your math support person. We are all here to help. Thank you.